Now that you've learned about the blood and its composition and how it reacts, and we can actually use it to figure out what happened at a crime scene, let's look a little bit more closely at that last point, figuring out how to reconstruct a crime scene and what the blood is actually telling us. And we'll look at the blood spatter. So blood spatter is actually a group of blood stains, and it helps to reconstruct the crime scene by determining the direction the blood was traveling. Then we can figure out the angle of impact. So, if the assailant was standing at an upward angle or at a downward angle, and the point of origin of the blood, where it actually came from, and determine the manner of death based on the velocity of the spatter, because we can look at a low velocity spatter and a high velocity spatter, which being more like a fine mist from a something like a gunshot. So a little history on blood spatter analysis. In 1894, Petorsky wrote the earliest reference to it, but 1902 is when Dr. Glaister actually describes 6 patterns that classify blood spatter. And in 1939, Bathazard was the first to analyze the meaning of those patterns. So if we saw it, what did that actually tell us? 1955 is when blood spatter was used in the Sam Shepard case to exonerate him, and in 1971 is when Dr. McDonald used blood spatter in modern forensic examination, closer to what we use it for now. So there's spatter for different reasons, and blood is a thick mixture of cells and plasma, and gravity is going to pull it downward if you're injured, and the droplets are going to become longer than they are wide because of that gravity. So if you think of something kind of slowly dripping off a surface, and that's what the blood is doing. And blood is cohesive, so it actually sticks to itself. And because of its cohesive property, droplets are around it because the blood is going to stick to itself. So when it falls, it's going to kind of stick together. But every once in a while, some of the blood's going to separate from that main droplet, and you get little droplets around it, and those are called satellite droplets. So we're going to see satellites if we're looking at droplets that are on a porous surface, and the edge of the drop is going to form spikes that we'll look at later. And a porous surface might be wood or something like ceiling tiles, but if blood falls on a smooth surface like glass or marble, the edge of the drop is going to be very circular. So let's look at those 6 classification patterns. The first is a passive fall, and this is going to happen when blood falls at a 90-degree angle to the floor, and you get these circular drops. Now, depending on the surface is what's going to determine whether you have really round drops or you have spikes at the end. So if we look at over here, we actually see that there's some droplets that come out, and you see that these aren't perfectly round circles, but you have little spikes. That would be a satellite. Okay, so these outside droplets are satellites. An arterial spurt, something that you would see in like a horror film, happens when blood is actually going to gush from an artery, and it hits the walls or the ceilings depending on the angle that the victim is at. And it causes these spurts. If you see, it's like a big blob and then a little bit and a big blob. It's because the heart is pumping. So the heart's pumping, and as it's pushing, it's kind of spurting out of the artery. Next, we have what's called splashes, and they're kind of shaped like exclamation points, and they help locate the position of a victim, because we know that we're going to have the bigger part of the drop at one end coming from where the victim was, and then we're going to get the smaller droplet, or the bottom of the exclamation point, going in the other direction. And then we have blood smears, which are caused when somebody that's bleeding kind of brushes up against something and wipes some of that blood. And then trails can either be blood drops, smears, or spurts as a bleeding victim moves from one place to another. And a blood pool is a pile of blood basically that forms around a victim that's bleeding heavily, and that stays in one place. So when we're looking at spatter, we can figure out the type of wound, because a fine mist spatter is from a high velocity weapon like a gun, and a low velocity spatter is from a slow moving object. And there you're going to see larger drops. And if there was an object that was there at some point, we might see a void. And a void is actually just an empty space in the blood pattern, because there was something there when the blood sprayed around it. And we can also figure out the angle of impact and point of origin. So let's look more at that. To figure out the angle of impact, you're actually going to take the arc sine of the width and the length, and that's going to give you your angle. So you'd measure the length of the blood drop, okay, so the longest part of the blood drop and the width, and then you plug it in to your equation. So you take second sine of whatever the width divided by the length is, and that gives you the angle of impact. So a blood drop that's perfectly round fell at a 90-degree angle, but a blood drop that's 20 degrees, or that looks like this, will be from a 20-degree angle. And you notice that as the angle gets smaller, the blood drop gets longer. And let's talk a little bit about cast off. So cast off is actually what's left over as somebody's hit multiple times. So the first time someone's hit, that causes them to bleed. And then the subsequent blows are going to kind of fill the weapon with blood. And as they raise that weapon, they're going to actually have some of the blood come off the weapon onto the surfaces around it. And then we can actually calculate that as well. So the pattern and intensity of that depends on the type of weapon and the amount of blood that's actually adhering or sticking to the weapon and the length of the arc. So if we look at the downswing of a hammer, and we're going to see this hammer hit this statue, in this case, on the head, then that causes the bleeding. That's the first blow. But as they come back, this is going to cause blood droplets or cast off to hit the ceiling. And as the backswing is happening and arcing, you're going to get a blood pattern. So we get directionality by looking at the blood droplet shape. So if it's circular, we know that it came from a 90-degree angle. And then we can, of course, figure out the angle by measuring the length and the width and hitting second sine. If it's elongated, we can figure out the direction of travel. So like I showed you before, the exclamation points or these splashes will show us that the victim was over here and the blood was traveling outward this way, the direction of the arrows. Then from there, we can actually draw a line of convergence down the long axis of the spatter. So if we look at these splashes up above, we can draw a line down the middle of that in the direction of travel. And where all the lines intersect is the point of origin. So if we look at this diagram a little closer, here's your blood pattern on the bottom. And if we draw a line down the middle and we figure out the angle, we attach some strings. Where they all intersect, this is where the victim was standing when they were injured. So to figure out point of convergence, look at it a little closer. We have all these, blood patterns, this blood spatter. We're going to just draw lines down the long axis of each blood droplet and in the direction of travel. And where they intersect is where the blood came from. So this was actually two separate instances. Here we have one where my mouse is going now, and then here's another one. And if we look at gunshot spatter, we can see that there's actually backward and forward spatter. So if we have a piece of foam and it's bloodstained and the gun was shot through, or the bullet was shot through the foam, there's the foam, we can see that the bullet was passing left to right, okay, just above the sheet. The bullet came in here, and you see that the bullet came in here and the foam was over in the middle. So we actually ended up with blood going backwards. That's the back spatter. All of this going forward is forward spatter. Okay, so we have the back spatter on entry, and then as the bullet exits, it will cause forward spatter. And then there's other things we can do to find blood evidence. We can use a chemical called luminol, which detects blood that may not be seen originally because the person tried to clean it up. And all it does is it kind of glows or fluoresces when you spray it onto blood. And when it appears there's blood, there's some questions that we have to ask as we go and investigate. The first is that we have to confirm that the stain is blood. And to do that, we use a Kastle-Meyer test is the most popular, and it produces a dark pink color, which I show you down here. With the test, you get this pink color if it's positive and the stain is actually blood. The other one is the leukomalachite green. Similar, it'll produce a green color if blood is present. And then once you figure out that, yes, it is blood, you have to figure out that the blood is human. And, we could be looking at a scene that was staged. It could be real blood, but it might be cow's blood. So you confirm that the blood is human by using an ELISA test, which is an antibody reaction test. And the last thing is, if it is human blood, you're going to determine the blood type.